50 facts about sequences and series. Basic concepts. 1. A sequence is an ordered list of numbers. 2. Each number in a sequence is called a term. 3. A series is the sum of the terms of a sequence. 4. Sequences can be finite or infinite. 5. Series can be finite or infinite. 6. The north term of a sequence is denoted by a, n, or t, n. 7. An arithmetic sequence has a constant difference between consecutive terms. 8. A geometric sequence has a constant ratio between consecutive terms. 9. The common difference in an arithmetic sequence is denoted by d. 10. The common ratio in a geometric sequence is denoted by r. Formulas and properties. 11. The north term of an arithmetic sequence is a, n, equals a plus, n1, d. 12. The north term of a geometric sequence is a, n, equals r caret, n1. 13. The sum of the first n terms of an arithmetic series is s, n, equals n, 2, 2a plus, n1, d. 14. The sum of the first n terms of a geometric series is s, n, equals a, 1r caret n, 1r, if r does not equal 1. 15. The sum of an infinite geometric series converges to a, 1r, if r less than 1. 16. Sigma notation, sigma, is used to represent the sum of a series. 17. The harmonic series, 1 plus 1/2 plus 1/3 plus, diverges. 18. The p series, 1 plus 1/2 caret p plus 1/3 caret p plus, converges if p greater than 1 and diverges if p is less than or equal to 1. 19. The geometric mean of two numbers a and b is square root, ab. 20. The arithmetic mean of two numbers a and b is a plus b, 2. Convergence and divergence. 21. A sequence converges if it approaches a finite limit as n approaches infinity. 22. A sequence diverges if it does not converge. 23. A series converges if the sequence of its partial sums converges. 24. A series diverges if the sequence of its partial sums diverges. 25. The north term test for divergence states that if lim, n right pointing arrow infinity sign, a, n, does not equal 0, then the series diverges. 26. The geometric series converges if r less than 1 and diverges if r is greater than or equal to 1. 27. The harmonic series diverges. 28. The p series converges if p greater than 1 and diverges if p is less than or equal to 1. 29. The integral test can be used to determine the convergence or divergence of certain series. 30. The comparison test can be used to compare a series to a known convergent or divergent series. Special sequences and series. 31. The Fibonacci sequence is defined by f, n, equals f, n1, plus f, n2, with f, 1, equals f, 2, equals 1. 32. The golden ratio is approximately 1.618 and is related to the Fibonacci sequence. 33. A power series is a series of the form sigma, a underscore nx caret n. 34. A Taylor series is a power series representation of a function. 35. A Maclaurin series is a Taylor series centered at x equals 0. 36. The binomial series is a power series expansion of 1 plus x, caret n. 37. A telescoping series is a series where most terms cancel out. 38. An alternating series is a series whose terms alternate in sign. 39. The alternating series test can be used to determine the convergence of certain alternating series. 40. The ratio test can be used to determine the convergence or divergence of certain series. Applications. 41. Sequences and series are used in finance to calculate interest, annuities, and loan payments. 42. Sequences and series are used in physics to model motion, waves, and electrical circuits. 43. Sequences and series are used in computer science for algorithms and data structures. 44. Sequences and series are used in statistics for probability and distributions. 45. Sequences and series are used in biology to model population growth and genetic inheritance. 46. Sequences and series are used in engineering to design structures and systems. 47. Sequences and series are used in economics to model economic growth and inflation. 48. Sequences and series are used in game theory to analyze strategies. 49. Sequences and series are used in cryptography to encode and decode messages. 50. Sequences and series are used in music to create harmonies and melodies. 50 more facts about sequences and series. Deeper dive into sequences. 51. A recursive sequence defines each term in terms of previous terms. 52. The Fibonacci sequence is a classic example of a recursive sequence. 53. A harmonic sequence is a sequence of reciprocals of an arithmetic progression. 54. A geometric mean sequence is a sequence where each term is the geometric mean of the preceding and succeeding terms. 55. A bounded sequence is a sequence whose terms are all between two fixed numbers. 56. A monotonic sequence is a sequence where the terms are either all increasing or all decreasing. 57. The limit of a sequence is the value that the terms approach as n approaches infinity. 58. A convergent sequence has a finite limit. 59. A divergent sequence does not have a finite limit. 60. The Cauchy criterion can be used to determine if a sequence converges. Advanced series topics. 61. An absolute convergent series is a series whose absolute values converge. 62. A conditionally convergent series is a series that converges but whose absolute values diverge. 63. The ratio test is often used to determine the convergence of a power series. 64. The root test is another test for convergence of series. 65. The limit comparison test compares two series to determine convergence. 66. The alternating series test is used for alternating series. 67. The Dirichlet test is a generalization of the alternating series test. 68. The Abel test is another test for convergence of series. 69. A power series is a function defined by an infinite series of powers of x. 70. The radius of convergence of a power series is the distance from the center where the series converges. Applications and extensions. 71. Taylor series can be used to approximate functions. 72. Maclaurin series are Taylor series centered at x equals 0. 73. Fourier series represent periodic functions as sums of sine and cosine functions. 74. Generating functions are used to study sequences and series. 75. Difference equations are related to sequences and can model various phenomena. 76. Fractals can be generated using recursive sequences. 77. The zeta function is a complex function related to the Riemann hypothesis. 78. The Euler-Maclaurin formula connects sums and integrals. 79. Asymptotic series are series that provide approximations for large values of x. 80. Hypergeometric series are a class of special functions defined by series. Miscellaneous facts. 81. The sum of an infinite geometric series with r less than 1 is a 1r. 82. The sum of the first n natural numbers is n plus 1, 2. 83. The sum of the squares of the first n natural numbers is n plus 1, 2n plus 1, 6. 84. The sum of the cubes of the first n natural numbers is n plus 1, 2, 2. 85. The factorial of a non-negative integer n is denoted by n, and is the product of all positive integers less than or equal to n. 86. The binomial theorem expands a plus b, n. 87. Pascal's triangle gives the coefficients of binomial expansions. 88. The Catalan numbers count various combinatorial objects. 89. The Euler number e is the base of the natural logarithm. 90. The number pi is the ratio of a circle's circumference to its diameter. Historical and mathematical connections. 91. Archimedes calculated the area of a circle using a method related to sequences. 92. Zeno's paradoxes involve sequences and limits. 93. Leibniz and Newton independently developed calculus, which is closely related to sequences and series. 94. Leonhard Euler made significant contributions to the study of sequences and series. 95. Bernard Riemann studied the zeta function and its connection to prime numbers. 96. Cauchy developed rigorous definitions of limits and convergence. 97. Weierstrass created the concept of uniform convergence. 98. Borel introduced the concept of summability. 99. Hardy and Ramanujan made significant contributions to the theory of partitions. 100. The study of sequences and series continues to be an active area of research. Would you like to